Hi, welcome dear students. Today's class on different problems, different kinds of problems we are going to discuss. In the previous class also we discussed many problems on allied angles, right? And this class also we are going to discuss different kinds of problems on these allied angles, right? Now on part of that. This is what you are having if alpha and beta are complementary angles such that they given that sine alpha equal to p by q, right? Then find the value of sine alpha cos beta minus cos alpha sine beta, like this, right? How we are going to do this particular problem, you please observe, my dear students. They given that alpha and beta are complementary angles. That means alpha plus beta is equal to 90 degrees, like this, right? Alpha plus beta is equal to 90 degrees, right? That means we are going to have here beta is equal to, right, 90 degrees minus alpha, right, in this way. And alpha is equal to 90 degrees minus beta. Which one is useful, that we will take, like that. Which one is useful, that we will be taking, and we will do the things here, like this. Now they given here sine alpha is equal to p by q, right? Fine. They given sine alpha equal to p by q. That means, my dear students, you see here sine of alpha now only we got this as 90 degrees minus beta, like this. Sine 90 minus beta, you know that is cos beta, right? This is nothing but sine alpha. Alpha value is this. That is nothing but we have got it as cos beta, that is equal to p by q, right? Because we have replaced alpha by 90 degrees minus beta. From that we got sine alpha as p by q and cos beta also p by q. But we need to find here this one, like this, sine alpha cos beta minus cos alpha sine beta. This is what we require to find. For that, you see, we know sine alpha, let us find cos alpha. We know cos beta, we know, let us find sine beta, like that, right? Fine. Now you see what we are going to do is sine alpha equal to p by q, like this. Let us take this right angle triangle, like this, right? If you take this is what angle alpha, like this. Let us take this as some a b c, like this. Sine alpha is opposite side and hypotenuse is q, like this. And AB is nothing but root over q square minus p square by Pythagoras theorem. You know that, right? Root over q square minus p square. That you know, of course, very easily. And of course, from this sine alpha, we know we want cos alpha. Like cos alpha is equal to root over q square minus p square by q, like this, right? Adjacent side by hypotenuse. That is what cos alpha we have got here, like this. Next, we know here cos beta, right? Cos beta. Fine. This is what angle beta here. Let us take this is something like PQR. Cos beta, they have given it as P by Q. Cos beta means adjacent side. Adjacent side is P and the hypotenuse is Q, right? Now, in this one, you are going to get this side by Pythagoras theorem. Okay, RQ, you are going to get it as Q square minus P square. Q square minus P square. Now, we know cos beta we know. And let us find here sine beta from this. Let us find here sine beta from this, like this. Right? Sine beta. What you will get sine beta is nothing but root over Q square minus P square. Opposite side by hypotenuse, that is by q, like this. Okay, this is what you call perpendicular, however, perpendicular by hypotenuse. Okay, here cos alpha means the base or adjacent side by hypotenuse, like this. Now we have got sine alpha. Wonderfully, we know they given sine alpha, and from that we found here cos alpha nicely, and also here you know cos beta, you know here, and from that you found here sine beta also. These all what we kept in boxes. These four. Now they are asking you to find sine alpha cos beta minus cos alpha sine beta. Now you see here, this is what sine alpha cos beta minus cos alpha sine beta, like this, right? Now sine alpha is equal to p by q, right, into cos beta. cos beta is also equal to P by Q minus sin alpha cos beta minus cos alpha. Cos alpha is root over Q square minus P square by Q, right? Into, right, cos alpha into sin beta, that is also root over Q square minus P square by Q, like this, right? Once we have got this one like this, this is nothing but P square by Q square minus this is also under denominator Q square, and it is multiplied like this, that you know that this is nothing but Q square minus P square, like this, right? Once you take the LCM part here like this, once you take the LCM part as Q square here, then you are going to get P square minus Q square plus P square, like that, right? That what you are going to get it as P square minus Q square minus into minus, this you are going to get, right? Once we have got, we are almost done our problem. That is nothing but you are going to get 2P square minus Q square by Q square. That is what the value you are going to get from that, of course. See, the ultimate result what you have got is here I am writing once again 2P square minus Q square by Q square is what the answer. This is what the answer you are going to get, right? Now the second problem, very interesting problem. They given A, B, C are the angles of a triangle. Then show that cos of A plus 2B plus 3C by 2 plus cos of A minus C by 2 is equal to 0, right? What we require to prove is, see, they given that A, B, C are the angles of the triangle. That means A plus B plus C is equal to 180 degrees, like this, right? A plus B plus C is equal to 180 degrees, right? Wonderful. Now we need to prove this one, left hand side we require to do that. That what let us take, my dear students, here. First cos of, let us find A plus 2B plus 3C by 2, like this. Let us find this first, right? The left hand side part. Okay, first we took this one and let us try to get this value here, of course. Now cos of this is equal to A plus 2B, I can write it as 2B, I write it as 1B, and 3C I can write it as A plus B plus C, and here one more B is left, that B I have written, and 2C, like this. I splitted that 3C, I used 1C here and another 2C is here, and 2B, 1B used here and one more thing here, like this. Whole by 2 you are having like this, right? This is what we have here, like. Very good. Now this is cos of A plus B plus C. Already you know that it is given 180 degrees, right? 180 degrees plus B plus, right? This 2C, once again I will write it as B plus C whole by 2 we will write like this, right? And one more thing, you know that, my dear students, here B plus C, once we know that A plus B plus C equal to 180 degrees, B plus C is nothing but 180 degrees minus A, like this, 180 degrees minus A, like this, right? And let us write that here, find. Okay, let us use this fact we use, and let us substitute here like this. This is equal to, we are going to get that cos of 180 degrees plus B plus C, already we got it as 180 degrees minus A plus C whole by 2, like this. Okay, wonderful. Now you see, my dear students, this is equal to cos of 180 degrees plus 180 degrees is 360 degrees minus, if you take common, you are going to get A minus C whole by 2, like this. This is nothing but cos of 360 by 2 is nothing but 180 degrees minus of A minus C by 2, like this, right? Wonderful. Now cos 180 degrees minus theta is minus cos theta. That means minus cos theta. In the place of theta, you are having A minus C by 2, like this. Wonderful. That means we have got this, and if you add, you take now the left hand side part. Okay. Now you take the left hand side, you have here, now we got almost the problem, right? That is what left hand side is, cos of A plus 2B plus 3C by 2. That only now we simplified, that we have got it as minus cos of A minus C by 2 plus right? Cos of a minus c by 2. This is cos of a minus c by 2. They both cancelled and we got it as 0. That is what the right hand side part. How beautifully we have got the result. You please observe, dear students. This is the way how you do this type of particular problems. Now we have the third problem, which is very important and asked in many times these type of problems in competitive examinations. What is this? Is if 3 sin theta plus 4 cos theta equal to 5, then show that 4 sin theta minus 3 cos theta equal to 0. Right? This is what our problem. How we are going to proceed, my dear students, you just observe. Okay, they given that here, given, this is what given, 3 sin theta plus 4 cos theta is equal to 5. This is what they have given like this. Okay, and we need to find this value. We need to find this value. That is what 4 sin theta minus 3 cos theta is equal to k. We want to find the k value, okay, and that we require to prove it as 0 because we need to show that. That means we have to prove that k value as 0 like that. Right, my dear students, now how we are going to proceed is, we know two equations here. Let us call this as equation number 1 and we call this as equation number 2 like this. Right, once we have got these two equations, what we do is, let us do equation 1 square plus equation 2 square. We do here like this. Equation number 1 square plus 2 square. Let us do, okay, this part there. Now this is what we are going to get, 3 sin theta plus 4 cos theta whole square plus 4 sin theta minus 3 cos theta whole square. This is equal to, we are going to get it as 5 square plus k square. Squaring and adding their respect to left hand side spots and their respect to right hand side spots here. Once we do this, my dear students, what we are going to get this particular equation, this you know that 9 sin square theta, right, plus, okay, a plus b whole square formula. This is what, a square plus 2ab, 2 into ab, 2 into 3 into 4, 6, 2 into 3, 6, 6 into 4, 24 sin theta cos theta you are having here like this, plus 16 cos square theta like this, plus 4 sin theta, this is now 16 sin square theta, plus 9 cos square theta you are having here like this, and minus, this is 24 sin theta cos theta you are having here, sin theta cos theta, that is equal to, right, my dear students, 5 square plus k square. That means 25 plus k square you are having this value. Now you can easily observe, very wonderful, we can okay, this cancel, minus 24 sin theta cos theta plus 24 sin theta cos theta, and we are having 9 sin square theta. Let us take here 9 common here, then we are going to get sin square theta, right, plus cos square theta, right, like this. 9 if you take common. In the similar way, 16 if you take common here, you are going to get cos square theta plus sin square theta in this, because 16 cos square theta, 16 sin square theta. This is equal to 25 plus k square you are having like this. Now you know that, my dear students, 9 into sin square theta plus cos square theta, you know it is from square relations, it is 1, plus 16 into cos square theta plus sin square theta is 1, that is nothing but 25 plus k square you are having here. Now 9 into 1 plus 16 into 1, that is nothing but 25 is equal to 25 plus k square you are having. From that you can say that k square value equal to 0, from that k value equal to 0. That is what we require to prove. We have got k value equal to 0. Therefore, my dear students, we have proved that 4 sin theta minus 3 cos theta is equal to k, and that value we got it as 0. This is what we require to prove. This is the way how we will do this particular problem. Whenever they give like this, they don't know, that means we take it as k and we proceed further, and we will be getting the problem. It is a very important problem. This is asked many times in competitive examinations. Now we have a wonderful problem, the fourth one. If tan 20 degrees equal to lambda, then show that tan 610 degrees plus tan 700 degrees by tan 560 degrees minus tan 470 degrees equal to 1 minus lambda square by 1 plus lambda square. This is what we require to prove. Right, let us express everything in terms of lambda, this particular problem, right, and then we will get the problem, right. For that part, we taken the first one, tan 610 degrees. I think we can write this tan 610 degrees as tan 720 minus 110, like this. 720 you can write it as 2 into 360 degrees minus 110 degrees, like this you can write. Right, now this is something like n into 360 degrees minus theta, that you can write it as like it is in the formula in the fourth quadrant, that you can write as minus tan 110 degrees, like this, minus tan 110 degrees, and that we can write it as minus tan of 90 degrees plus 20 degrees, that become minus of minus tan 90 plus 20 become minus cot 20, minus into minus plus cot 20 degrees, and that become 1 by tan 20 degrees, that is equal to 1 by lambda. You have got. In the similar way, let us do tan 700 degrees here, like this, tan 700 degrees. Let us do this in terms of lambda, we will get like this. This is also, my dear students, what we are going to do is tan 720 degrees minus 20 degrees, we can write like this, right. In the same fashion, this you can write it as 2 into 360 degrees minus 20 degrees, like this, right. N into 360 degrees minus theta, n into 360 degrees minus theta, that is that formula is minus tan theta, that means minus tan 20 degrees, like this. This is nothing but minus lambda value here. We got this as minus lambda value here, right. Next, let us in the same fashion we do tan 560 degrees, like this. This we can write it as tan, right, 560 degrees we can write it as 360 degrees plus 200 degrees, we can write like this. Tan 360 plus theta is nothing but tan theta, that's why tan 200 degrees you have got here, like this. This 200 degrees, once again we write 200 degrees, we will write this as in terms of 20, we want 180 degrees plus 20 degrees, we write like this. Tan 180 plus 20, tan 180 plus theta, that is in third quadrant, and it become tan theta only. That means tan 20 degrees you have got this, and that as lambda only, like that is nothing but you have got this value as lambda only, right. Fine. Now the only the last one is left here, tan 470 degrees, like this. Tan 470 degrees you can write it as tan, right, 360 degrees plus, right, tan 360 plus 110 degrees, that is nothing but now once again tan 360 degrees plus theta will be tan theta, therefore this is now tan 110 degrees, my dear students. Now this become tan 90 degrees plus 20 degrees, like this. Tan 90 plus 20 degrees is nothing but what you will be getting is minus cot 20 degrees, like this, right. This is what minus cot 20 degrees. This is nothing but minus 1 by tan 20 degrees, like this. Minus 1 by tan 20 degrees, this is now minus 1 by lambda, like this, right. This is minus 1 by lambda. Wonderful. Therefore, let us take our problem, what we have got the left hand side part here, right. Once we get these all the things, the left hand side, first one tan 610 degrees is nothing but we have got it as 1 by lambda. I am doing it directly. 1 by lambda, the first one, plus tan 700 degrees, we have got it as minus lambda, whole thing divided by tan 560 degrees. Tan 560 degrees, we have got it as lambda here. This is lambda, right. Tan 470 degrees. Tan 470 degrees, we have got it as minus 1 by lambda. Now our job is to simplify this and get our right hand side part like this. Here you see, you don't have this and lambda by 1, the answer, this LCM is lambda, right. And 1 minus this is lambda square, we are going to have like this. And the whole thing divided by here also the LCM is for the denominator part is lambda. For the denominator part, the LCM is nothing but you see here, my dear students. For this also lambda is what the LCM part here like this, right. Here I am writing like this. Wonderful. And this you are going to get it as lambda square minus 1 like this. Wonderful. Lambda square. Fine. And here you see, here we are having here minus. This is minus. Therefore, this is minus of minus. This become, we are going to get plus, right? This is plus because we are there, we are having minus. Minus into minus plus. And this is lambda square plus 1. Now this lambda will be cancelled. Now you have got it as 1 minus lambda square by 1 plus lambda square. This is what the right hand side part you require to prove. Therefore, you have taken nicely the left hand side part and you got this right hand side part. In this way, you need to express all these given trigonometric ratios in terms of tan 20 degrees, and that will be expressed in terms of lambda. Finally, you simplify, then you will get our desired right hand side part. In this way, this beautiful problem can be answered. Now we have one more fabulous problem. Fifth one, if cosecant theta plus cot theta equal to 1 by 5 is given, find all other trigonometric ratios. We need to find all other trigonometric ratios. Means 6 trigonometric ratios we need to find, and find the quadrant in which theta lies, right? We need to find all trigonometric ratios here like this. How we proceed this beautiful problem? We know that we have one square relation, cosecant square theta minus cot square theta is equal to 1. That means, you know that they write cosecant theta plus cot theta into cosecant theta minus cot theta like this. This is equal to 1. And 1 is reciprocal of the other. You know that in mathematics, whenever we say that a into b equal to 1, a you can write it as 1 by b, or b you can write it as 1 by a like this. Both are reciprocals to each other. Now from this factor we get that cosecant theta minus cot theta is equal to 1 by cosecant theta plus cot theta like this. 1 by cosecant theta plus cot theta. And that is nothing but 1 by cosecant theta plus cot theta is 1 by 5 like this. 1 by 5 is nothing but 5. You have got like this. Now wonderfully you have got two equations, right? From this now you see, my dear students, cosecant theta minus cot theta is equal to, okay, one thing you have got here it as 5, and another one cosecant theta plus cot theta is equal to 1 by 5 like this. Now let us add this, and from that we are going to get 2 cosecant theta is equal to 5 plus 1 by 5 like this, right? Once we have got this, this is nothing but if you take LCM, that you are going to get it as 26 by 5 like this. And from this cosecant theta, you are going to get 26 by 10. That is nothing but 13 by 5 like this. Okay, wonderful. Once we got this as 13 by 5 in this way, right, we will get even cot theta. We know that cosecant theta, well, let us use any one of the equation here. Cosecant theta minus cot theta is equal to 5 like this, right? Now we know cosecant theta is 13 by 5, like 13 by 5 minus cot theta is equal to 5 like this. 13 by 5 minus 5 is equal to cot theta. You have like this. And of course this is cot theta, you are going to get 13 minus 25 by 5 like this, right? 13 minus 25 is nothing but minus 12 by 5. From this we have got one wonderful observation. Cosecant theta is positive, cot theta is negative, where it is possible. Where it is possible. That is what we observe. Here cosecant theta is positive means it is possible either in first quadrant or second quadrant, because all silver teacups, silver means sine and 1 by sine is positive, and cot theta is negative. That means right, it cannot be in the first quadrant, because in first quadrant all are positive. That means cot theta is negative means cosecant theta positive means this is possible only in second quadrant. In second quadrant cosecant theta 1 by sin theta is positive and cot theta become negative. This is possible only in second quadrant. Therefore theta belongs to Q2. Q2, right? One answer we have got here. Now we need to find other trigonometric ratios. That is very simple part, right? How we are going to do that part is nothing but you write this thing theta we have here like this, right? And find cosecant theta, they have given it as 13 by 5. 13 means this and 5 is this, like this. Once this is 13, this is now 12, we have got here like this. Now let us find all other trigonometric ratios, right? Sin theta from this. Sin theta you are going to get 5 by 13, and cos theta you are going to get it as 12 by 13, right? And tan theta you are going to get it as something like opposite side by adjacent side, 5 by 12, like this. And cot theta, of course, you know, we got it as like 12 by 5, and we write all these signs here, of course. Secant theta from this. Secant theta is nothing but hypotenuse by adjacent side. And in quadrant 2, which are positive? Which are positive means sin theta is positive. And cosecant theta already given that it is positive. And remaining all are negative. This is negative, 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 negative. Like this, wonderfully we can do this particular problem. This is very, very important. That's why I am explaining with more concentration, right? Now we have one more fabulous problem. Prove that 6 to 1 tan theta plus secant theta minus 1 by tan theta minus secant theta plus 1 is equal to 1 plus sin theta by cos theta. This is what we require to prove. How we do? Let us take the left hand side part, my dear students, here. And this is now tan theta plus secant theta, right? Minus 1 we are having here like this. This minus 1, we know square relations, we use this as secant square theta minus tan square theta, right? We write that because we know that left hand side part we have taken in the place of 1. In the place of 1, we are writing secant square theta minus tan square theta, and divided by, this is now tan theta minus secant theta plus 1 we are having like this. Now this is equal to, right, my dear students, this is now tan theta plus secant theta minus of this. Let us split it. We know a square minus b square. Secant theta minus tan theta into secant theta plus tan theta, like this. Secant theta plus tan theta, right? Like this we write here. Whole thing divided by, we have here like tan theta minus secant theta plus 1 we have like this, right? And this is what the terms we are having. In these both terms, I think in the numerator, tan theta plus secant theta, tan theta plus secant theta, this is common. Let us take that one as common, right? Tan theta plus secant theta. That if you take common, tan theta plus secant theta, or secant theta plus tan theta, if you take common this particular term, then we are going to have here, once you taken this 1 minus of, right, you are going to have here like this, 1 minus of this, I am writing directly 1 minus secant theta minus into minus plus tan theta, like this. This is what we are going to have common like this. This is because after taking common this one, and 1 minus of secant theta minus tan theta, once you expand, open the brackets, that is minus secant theta minus into minus plus tan theta you are having here. Now this becomes, right, the denominator also we can write like this. Now the denominator 1 we have here, minus secant theta here, plus tan theta we have here. The denominator also we can write in this form. Now this and this will cancel here. 1 minus secant theta plus tan theta. That will be cancelled, and we have got wonderfully tan theta plus secant theta. And this tan theta plus secant theta we can write. You see here we have got it as like this. Tan theta plus secant theta, right this. And my dear students, tan theta plus secant theta, you know that tan theta is nothing but sin theta by cos theta plus secant theta means 1 by cos theta. Once you take the LCM here, cos theta you have here, and this becomes sin theta plus 1, that we can write as 1 plus sin theta, and that is what the right hand side part you require to prove. How beautifully we got this particular problem. You please observe what we did is here we used the square relation identity, secant square theta minus tan square theta, and we expanded this. We took common tan theta plus secant theta from the numerator. Once we took common, this is 1 minus of secant theta minus tan theta you expand the bracket, minus secant theta minus into minus plus tan theta, these will be cancelled. Now tan theta plus secant theta, you can write it as sin theta by cos theta plus 1 by cos theta. That means 1 plus sin theta by cos theta, that is nothing but the right hand side part. Right, in this way beautifully we can do this particular problem. We have one more fabulous problem for this video. The seventh one, prove that 3 times of sin x minus cos x whole power 4 plus 6 times of sin x plus cos x whole square plus 4 times of sin power 6x plus cos power 6x is equal to 13 we require to prove. Very important problem. Now let us do this problem. We will take one by one. Like first we take the first part, the first element here, sin x minus cos x whole power 4. Let us try to simplify this first. And what we are getting, let us observe this, right? Very good. Now this is, you see, sin x minus cos x whole power 4 we are having here. And what we do is here, let us write this as sin x minus cos x whole square first. And the whole square we write like this, right? Once we write like this, because that 4 we can write as whole square and whole square like this. Sin x minus cos x whole square, that is nothing but, you know, a minus b whole square sin square x plus cos square x minus 2 sin x cos x, right? Minus 2 sin x cos x whole square this. And of course this is nothing but sin square x plus cos square x is 1 minus 2 sin x cos x this. Right, whole square we are having. And of course this, if you simplify once again, you apply a minus b whole square formula. This if you apply, this is nothing but 1 plus a square plus b square minus 2ab. This is now 4 sin square x cos square x, right? A square plus b square minus 2ab, that means minus 4 sin x cos x you are going to get. Minus 4 sin x cos x you are going to get. This is what you have got, the first element of this. Now let us try to get the second element also. This, right? The second one we have here, sin x plus cos x whole square. This sin x plus cos x whole square. This you directly you can do a plus b whole square formula. This is now sin square x plus cos square x plus 2 sin x cos x, right? 2 sin x cos x. That is now sin square x plus cos square x is 1. 1 plus 2 sin x cos x you have here like this. Wonderful. Now the third element what is involved is here sin power 6x plus cos power 6x, right? This you write it as like this, right? Sin square x whole cube, right? And the cos square x whole cube we can write like this. A cube plus b cube formula, right? A cube plus b cube, that you can write it as something like, you know, a cube plus b cube is nothing but a plus b whole cube minus 3ab into a plus b. Use this fact. A cube plus b cube equal to a plus b whole cube minus 3ab into a plus b. That if you use a plus b whole cube, that is nothing but sin square x plus cos square x, right? Right, a plus b whole cube, that whole cube minus 3ab, 3 into sin square x cos square x into, right, a plus b. A is here sin square x plus b square, that is sin square x plus cos square x, right? Sin square x plus cos square x you are having. Of course, once you use this fact here, you know that sin square x plus cos square x is 1. Wonderful. That means this is 1 cube. You are having here like this, my dear student. This is 1 cube minus 3 into sin square x cos square x into 1. And of course, this is nothing but 1 minus 3 sin square x cos square x, like this. Okay. Now you take the left hand side part of you. This is left hand side part. You have got now 3 times of this sin x minus cos x whole power 4, that we got it as, right, sin x minus cos x whole power 4, that we have got it as, right? You see, if you simplify that, what we are going to get is something like, right, what we get, this is here, it will be cancelled and we got this as 1 like this. Wonderful. This is 3 into 1 plus 6 into sin x plus cos x whole square is nothing but 1 plus 2 sin x cos x, 1 plus 2 sin x cos x, right, plus 4 times of, this is nothing but 1 minus 3, right? Yes, 1 minus 3 sin square x cos square x. Now you see, my dear students, here we did small mistake here. This is what here 4 sin square x a square plus b square. This is here this part a minus b whole square, a square plus b square minus 2ab. Minus 2ab means minus 4 into sin x cos x, this sin x cos x, right? Be remembered here. Here now everything will be changing here. Now you see here that we are going to have here our left hand side part 3 into sin x minus cos x whole power 4 is nothing but, now let us put here 1 plus 4 sin square x cos square x minus 4 sin x cos x, like this 4 sin x cos x, right? And plus 6 times of, we have got sin x plus cos x whole square is 1 plus 2 sin x cos x, 2 sin x cos x, right? Wonderful. Next you have got 4 plus 4 times of this, 4 times of, right? Yeah, sin power 6x plus cos power 6x, you have got it as 1 minus 3 into sin square x into cos square x, right? This is what we have got. This is what our left hand side part we have here, like this. Now let us try to simplify this, right, my dear students? Since there is no space, I am using here to simplify that, right? Wonderful. Now this become, now see 3 into 1 3 plus 3 into 4 12 sin square x cos square x minus 12 sin x cos x minus 12 sin x cos x. So like this you have here. Now 6 plus 1 6, 6 into 2 12 sin x cos x plus 12 sin x cos x, right? Wonderful. Next this is now plus 4 minus 12 sin square x cos square x, sin square x cos square x, you have here like this, right? This is what we have got here. Now observe, my dear students, minus 12 sin square x cos x plus 12 square x cos square x will cancel, minus 12 sin x cos x plus 12 sin x cos x will cancel. Now 3 plus 6 9, 9 plus 4 3 plus 6 plus 4, that is equal to 13. 9 plus 4 13. This is what the right hand side part, how beautifully we have got this particular problem. Very good. Thank you for watching. Please subscribe, share it to your friends. Thank you very much.